Yes, student. Now, the next content is nomenclature of haloalkanes and haloarenes. So, in the nomenclature, there are two systems. One of the system, this is called common system of nomenclature, and one more system, this is called IUPAC system of nomenclature. IUPAC means International Union for Pure and Applied Chemistry. So two systems are there. Okay. Now suppose we denote Rx. So what should be the name of Rx on the basis of common system of nomenclature? So for nomenclature we have to find what is the prefix, what is the word root, and what will be the suffix for common system and then for IUPAC system. Student, in common system of nomenclature, it is considered that Rx, that is the halogen compounds, are derived by the alkane. Like here, these compounds are obtained by the alkane, means minus H and plus what? X. Getting? So it becomes CnH2n plus 1 dot what? X. Isn't it? So the prefix with word root is given by what? Alkyl. Given by alkyl. L, that is number of carbon atom, and one of the hydrogen is removed, therefore it becomes what? Radical. So become alkyl. Okay. And the suffix is written as halide. So now add alkyl plus halide overall, name become what? Alkyl halide. So this is the rules for common system. Like if I write first compound CH3X, then it will become what? One carbon atom is there. So one carbon atom is named as word root what? Meth. And being it is alkyl radical, therefore we have to write what? Yl methyl. Okay. And this is X, so this will become what? Halide. That is the suffix become methyl halide. If you write some more 1, 2, 3 and X. So how many carbon atoms are there? 3 carbon atoms are there. 3 carbon atoms, the word would become what? O. Okay. And what? Yl. And X is there, therefore it becomes what? Propyl halide. Okay. Similarly, if you write CH3, CH2, this is CH2 and this is what? X. Okay. Or this is X and there is what? CH3. Now the halogen is attached with what? Carbon. Which type of carbon is there? It is tertiary carbon, 3 degree carbon. Therefore, now we have to add a prefix what? Tertiary. What? Tertiary. Okay, for this one. And tertiary 1, 2, 3, 4 carbon atom. Therefore, this is become tertiary butyl. And what? Halide. The overall name becomes tertiary butyl halide. If I write C and X, there is H, or say CH3, this is CH3 and this is what? H. Okay. Now the halogen attached with the carbon, which is what? Secondary carbon. Therefore for secondary carbon the prefix is given iso and 1, 2, 3, therefore what? Propyl. Iso, propyl and what? Halide. So isopropyl halide. This is the common system of nomenclature. Isn't it? But in IUPAC system of nomenclature, the prefix is written as hello, and the suffix is considered as alkane. Alkane. So overall name will become what? Halo and alkane. Alkane, that is number of carbon atoms. The word root alk will be number of carbon atom, and the prefix will become what? Halo. For what? X. So what will be name of this compound? So first we have to write what? Halo, and one carbon atom is there. So one carbon atom containing alkane is named as what? Meth. And being it is alkane, therefore it is written as alkane. Okay, like this compound is simply what? Halo, and three carbon atoms are there, therefore written as propane. Halo, propane. Getting? Similarly, now for this one, now we have to give number to the carbon atom because here branch chain is present. So number will be given as 1, 2 and 3. Okay, while this CH3 is not considered, therefore it will become prefix, and the prefix is attached to second carbon atom, therefore it is written is 2. The substituent is what? CH3. So right here 2-methyl. This is what? Prefix. And now the halogen is attached with second carbon atom, again 2-methyl, 2, now what? Halo. 2-methyl, 2-halo, this one. And how many carbon atoms? 1, 2, 3. So for 3, the word would become what? Pro. Okay, and compound is alkane, that is single important, therefore become propane. So 2-methyl, 2-halo, propane. For what? This compound. This compound. Now the last compound, again we have to give numbering. Numbering in the say 1, this is 2, and now this is 3. Not here, because the longest carbon chain is 1, 2, 3. Here the longest carbon chain 1, 2, 3 or 1, 2, 3. But here 1, 2, 3. Only one chances is there. So now there is no substituent. So simply write 2 and what? Halo and 3 carbon atom. Therefore the word would become what? Pro and belongs to N. Therefore butane. 2-halo propane. This is the nomenclature. Okay. Yes. Now next one, nomenclature of haloalkanes and haloarenes containing what? Multiple bonds. Now multiple bonds means double bond and triple bond. Student, I am showing you the nomenclature, IUPAC nomenclature system. You have to work on common nomenclature of multiple bond containing compound. So I am writing here the rules for what? IUPAC. Okay, student, multiple bonds, okay, consider as functional group and is given even more priority, even more priority as compared to X. That is what? Halogen functional group. Okay, it is only functional group which is given very least priority as compared to multiple bond. That is what? In case of the multiple bond is present with the halogen functional group, then we have to give more priority to what? Multiple bond for numbering of carbon atom of carbon main chain. For example, I am writing one of the compound CCX. Okay, now it is what? Double bond containing compound. So we can start numbering from 1 to no. We will start numbering from what? 1 and what? 2. Why? Because if we are giving it number 1, then with number 1 carbon, one more functional group which is halogen is attached. So we will give more priority to double bond as well as functional group. There is not no option at all. So the name the name become halo. Okay, and how many carbon atom? 2 carbon atom. Therefore, it become eth. Okay, what root is what? Eth. And now, right, which carbon atom to which double bond is attached? It is attached with 1, and being it is double bond, therefore name is become ene. So the compound name become halo eth 1-ene, or you can also call it 1 halo eth 1-ene. Although there is no need to place the prefix what? 1. Why? Because there is no need to write 1. But in case of, if the compound is X, C, one more C, and now there is what? Double bond. Okay, here is a double bond. CH2, now CH and CH3X. In this way, now if we start numbering from this side, so it will consider that halogen is given more priority, but actually we have to give more priority in numbering of carbon atom of main carbon chain from the position where the double bond is nearer. That is, we have to start numbering from the side where the position of double bond is nearer. So we will start numbering. So 1, this is what 2, and this is what 3. So now the name is what? The name. It become what? Subsequent. So this is written as with third position halogen is attached. So 3 halo. Okay, and what root? 1, 2, 3. So this is what? Pro. And with which position double bond is attached? First position. So pro. Okay, 1 and what? Ene. Okay, this is the nomenclature system. Like if you write 1, 2, 3 and 4. Okay, and here is what? Cl. And there is double bond and one double bond also. Now, how do we number the carbon atom? First, complete the valency. The valency is completed. Okay, now what will be? How to number the compound? So we can start numbering 1, 2, 3, 4. But we can also start numbering 1, 2, 3, 4. Why? Because the position of double bond on all the sides is in same number carbon atom. Therefore, we have to concentrate, focus on the next functional group, which is what? Fluorine. So what? We will start numbering from left side rather than right side. Because in right side, now it will becomes in third position. But we start numbering from left side, then its position will be nearer. That is second position, and the double bond position also in first one. So now start numbering. So that becomes 1, this is 2, this is 3, and this is what? 4. So what will be the name? The name will be given. First write the subsequent position attached with what? Second number carbon atom, so 2, and the functional group is Cl. So that becomes 2 fluoro. Okay, and how many carbon atom? 1, 2, 3, 4. So it's what will become? But. What will become? But. And now the position of double bond. So first and third. So right here, but 1, 3. And how many double bond is there? 2 double bond. So for 2 double bond, write di and double bond. Therefore write here what? Ene. But remember, if 2 double bond are there, that is 2 multiple bonds are there, then you have to write in what? Buta. So besides of writing but, you have to use the term buta. So overall will become 2 fluoro, but will become buta 1, 3 diene. Okay. So in this way, you have to give numbering to carbon atom. Similarly, the same type of rules are also followed if the multiple bond is of type what? Triple bond. So can you work on this? Yes, you have to work the numbering and naming if the compound contains a triple bond. Similarly, similarly student, we can also write the name of haloarenes. Okay, I am naming in the same compound with you, say like this one. Okay, so this has become a fluorobenzene, simply. No need to write 1. So fluorobenzene. Okay. Suppose if two Cl position is there. Like one Cl is here and one Cl is here. Okay, then it become what? 1 2 dichloro, because two Cl is there, so 1 2 dichloro, and the prefix is become what? Benzene. Okay, it can also name as, now the position 1 2, so this is called what? Ortho, this is called what? Meta, and this one is called what? Para. So it become what? In ortho position, so we can write ortho, okay, dichlorobenzene, ortho dichlorobenzene, ortho dichlorobenzene. Okay, now if the compound is like that is mixed, means this one Cl. Okay, so this compound is known as benzyl, okay, chloride. It is what? Common system. It is in what? Common system. But in IUPAC system, we have to start numbering. So only one number is there, 1. So that becomes what? 1 phenyl. Okay, and see, one carbon is there only, so that becomes methane. 1 phenyl methane. So in this way, we can name the organic compound containing halogens. Yes, student, the next content is isomerism in haloalkane. Student, isomerism, it is one of the very important unique property of carbon compound. What is isomerism? It is the phenomenon where the same molecular formula having compound can be expressed by two or more than two type of formulas, that is structural formula or stereo formula or configuration. Getting? That is what? Two or more compound have same molecular formula, okay, but have different structural or stereo configuration. This phenomenon is known as isomerism, and all these compounds are called isomers. Now, student, you know that isomerism is mainly classified in two ways. First one is called structural isomerism, and the second one is known as stereo isomerism. Stereo isomerism. Okay. Now, what is the structural isomerism? If the structure of two or more compounds having same formula are different, called what? Structural isomerism. In structural isomerism, there are four types of isomerism. First one is called what? Chain isomerism. Second one is called what? Position isomerism. Third one is called what? Functional group isomerism. And the fourth one is called what? Metamerism. Okay. And in stereoisomerism, that is what? Stereo configuration means the spatial arrangement of atoms or group are different in two different compounds having two different formula but are having the same molecular formula. Such compounds are called stereo, or such isomers are called stereoisomerism. Now in stereoisomerism, again it is of first type. This is called geometrical isomerism. Second one is called optical isomerism. And third one is called conformational isomerism. But student, the heading, what is the heading? The heading is isomerism in haloalkane. So whether we have to check it by our knowledge and the discussion whether all these type of structural isomerism and the stereoisomerism are actually shown by haloalkanes. So here we have to use our intelligence, and this intelligence will be on the basis of definition of all these isomerism, and then we will apply out of these isomerism, which will be shown only by haloalkanes, not by all the compounds containing different functional group. Here we have to concise only up to the isomerism of haloalkanes. We have not to check all the isomerism or all the type of isomerism. So here we have to use our intelligence. Like here, what is chain isomerism? Chain isomerism is that where the carbon main chain having different number of carbon, okay, but the molecular formula is same. The position isomerism, the position of functional group is differ in two or more compounds, but again they are having same molecular formula. Functional group isomerism, that is the functional group in two compounds are different. Functional group in two compounds are different, but having same molecular formula. That means what? That means it will never possible with what? Haloalkane, because the haloalkane is having same type of halogen, say HCl, Br and I. If we write different HCl, Br, I 4 compound or 3 or 2 compound, then its formula will be changed. That means what? That means the functional group isomerism is not possible in haloalkanes. Similarly, metamerism, is it possible? It is again not possible, because here around functional group there should be different type of alkyl radical, but we know that the valency of halogen is only 1. So the functional group halogen can attach only with one alkyl radical, it cannot attach with two alkyl radical, therefore metamerism is also not possible. Get it? Similarly here in geometrical isomerism, it is again not possible, but optical isomerism is possible, and the conformational isomerism is again not possible. So the possible isomerism are what? Chain isomerism and what? Position isomerism and optical isomerism. So we will study about these three types of isomerism. What? First one, chain isomerism. What is that? Different, read what? Different number of carbon atoms having carbon main chain. Carbon main chain. Okay. So how to write it? So 1, 2, 3 and 4, and this is what? X. So 1, 2, 3, 4, and this is what? X. So this becomes one of the compound, and second compound we can write here having 3 carbon atom in carbon main chain, but one of the carbon atom is present as substituent, and this is what? Halogen. This is what? Halogen. So student, how many isomers are possible? 1 and 1, 2 isomers are possible, and these two are having the same molecular formula, what? C4H9X. Okay, so their name are also different. I can write its name. What is it? This has become halobutane. Halobutane. But here its name become what? Its name become 2-methyl and 3 carbon atom 2-methyl chloropropane. Simply, you can write here what? Sorry, not chloropropane. You can write halopropane. Halopropane. Okay. So halobutane to methyl halopropane. So this is called what? Chain isomerism. Second type of isomerism can be shown only what? Position isomerism. Means what? If the position of functional group X, it will be Cl and Bri. Okay, may be differ in more than two compounds having same molecular formula. Like here, 1, 2, 3, 4, 5. And now I am writing what? X. Okay, this become one of the compound. I can write one more compound. 1, 2, 3, 4 carbon atom in a main chain. Okay, I mean 5 carbon atom in a main chain, but the X is attached in second number carbon atom. And if I write 1, 2, 3, 4 and 5, and now the position of X in third carbon atom. So now complete the valency and write their IUPAC name. So what is its IUPAC name? It becomes 1 halopentane. 1 halopentane because halogen is attached in first carbon atom. Okay, this is called position. That is position of functional group are in different carbon atom of carbon main chain. Say this one is now the position. It is present in which carbon? Second carbon. So this is called 2 halo, and again carbon main chain is of 5. So that is 20. Isn't it? And what about the compound number third? Here the position is in which carbon? Third carbon atom. Therefore, it is written is 2 halo and what? Pentane. 2 halopentane. So these two types of isomerism are shown by haloalkanes. Getting? In case of haloarenes, haloarene. Okay. Again, the position isomerism is shown. Position isomerism is shown. How it is? It is like, say, one of the compound where X is present here and the next X is present here. One more compound where X is present here and the X is present here, and next one X is present here and the X is present here. So the position of X is in different number carbon atom of the benzene. Therefore, it is also known as position isomerism. Okay, it is called what? Ortho dichlorobenzene. It is called meta dichlorobenzene, and it is called para. This position is known as what? Para position. This is known as what? Meta position. And this one is known as what? Ortho position. So the position of functional group is different. Therefore, different type of isomers are possible. So these three type of isomerism is possible in haloalkane and haloarenes. Student, there is a question in our NCERT book. The question is, draw all possible isomers and their names. Okay, their name. Which name? Say simply IUPAC name of mono halo derivative. Mono halo derivatives of C5H12 compound. Okay, that is simply the question can be written as what? C5H11 anything X. Okay, because what? Mono halo derivative means If the formula is what? C5H12. So minus what? H plus what? X. So this is called mono-halo. Mono-halo means single halogen. And derivatives means made by the C5H12 compound. So the molecular formula is become what? C5H11X. So student, how to find? Okay, answer of these. So very simple. What you have to do? Okay, you don't do anything. You just focus on the main compound to which it is derived. The main compound is C5H12. And how many possible isomers are there? That is functional isomers, etc., or chain isomers, etc., are there. So C5H12 will not show functional isomerism. It can show only chain isomerism. And what are these? So isomers of C5H12 are as, say, number A, normal pentane. This is normal pentane. Okay. Number B is 1, 2, 3, 4. Okay, and this is CH3. This is called isopentane. Isopentane. Okay, and one more. What? Number C. This is called neopentane. Neopentane. Now, how to write neopentane? So 3 carbon atom in carbon main chain with 2 substituents. So CH3, CH3, and CH3. So actually what? The question is, we have to write its isomer. We have not to write its isomer. But what, to make the simplicity, I drawn the isomers of C5H12. So 1, 2, and 3. And now what I have to do? I have to put X in different positions. Taking all the possible positions. So if I put X in compound having these normal pentane, then 3 possibilities there. First possibility is 1, 2, 3, 4, 5, and place what? X here. Second possibility is 1, 2, 3, 4, 5, and put what? X here. And the third possibility is 1, 2, 3, 4, 5, and put what? X here. So what? 3 isomers are possible for C5H11X if we use this one. Okay, this is become what? Yes, 1, 2, and 3 possibility. If I draw for this one, now start placing X in each and every possible places. So how many possibilities are there? 1, 2, 3, 4. This is CH3. Place here what? X. This is one possibility. Write it here 1. Number 2 is 1, 2, 3, and 4. Okay. This is what? CH3. And now place second one X here. Third possibility is what? C, and this is what? C. Now what? Place X here. This is the third possibility. And one more possibility is there. What is this? 1, 2, 3, and 4. Okay, this is what? CH3. Place here what? X. This one is fourth possibility. Student, one more possibility. Okay, what should be the next possibility? The next possibility is CH3, CH3, and here what? X. So this is what? Next possibility. Now we have to find whether all these possible 1, 2, 3, 4, and 5 possibles are not possible. So for that what? We have to write their name. If we write name, what will become? 1, 2, 3, 4. That is 1 halo, 2 methyl butane or 2 methyl butane. Okay. But if you write here, again it will become what? Sorry, if you write here 1, 2 methyl. Okay. And 2 methyl 1 halo butane. So this compound is just similar to this compound. So cancel any one. Now suppose I am cancelling this one. So now the possible structures become only one. Okay. Next possibility is 2. Next possibility is this one. And the last possibility is this one. So total how many isomers are possible? 4 isomers are possible for the isopentane. And if for neopentane you place X any of the carbon atom, the name will be the same and the structure will also be same. So there will be what? 41 possibilities. That means what? That means if you find the answer, the total possibilities, okay, of isomers will be what? Will be 3 plus 4 plus 1. 3 for what? Normal pentane. Normal pentane. 4 for what? Isopentane. Isopentane. And 1 for what? Neopentane. So in this way, the total isomers possible are how many? 8. Now, can you write IUPAC name of all the compounds?